Hey everybody, my name's Derek. I'm a course assistant for PBL, and over the course of the project I'll be putting out a database of videos answering questions you might have specifically on computer modeling, SketchUp, Revit, or anything else you guys plan to use. I just wanted to start with a simple one today. There was a question about wall thickness in SketchUp and how things look like they have zero thickness. So I want to illustrate two ways of building a simple, let's say like a closet or a small room, and show you the difference between paper thin walls and walls with real thickness. So if I want to pick the rectangle tool and make first the floor of the building, and if you guys don't know this already, if you click the very first point and then start dragging out, you'll start to make a field for your rectangle. But at this point you can type in the numbers of the dimensions you want. So let's say I want a 10 foot by 8 foot room. Then I'll actually type in on the keyboard right now 10 feet, and you'll see it showing up in the bottom down here. 10 feet and 8 feet, separated by a comma. And when I click enter, it'll create the rectangle to that exact dimension. Now, most people, when they want to create a room out of this, they'll choose to use the push-pull tool. And then they'll select this field, and then be able to drag up after the first click. The same as what we did for the rectangle. At this point, you can type in the dimension of the height you want. So let's say you want this to be an 8 foot room. You'll type in 8 feet, enter, and your square will turn into a cube. Now what they'll do then is they will select the top, press delete, and notice that they've created a space which you can inhabit, but the walls themselves are paper thin. Now there's a second way to do this I'm going to show you right now, but let's quickly add a door for reference. So let's say they wanted a 3 foot by 7 foot door, and then they wanted to delete that face, so it looks like you have a room with a door, everything looks fine except the walls are paper thin. Now let's try a second way. So right over here I'm going to create the exact same floor base, so 10 feet, comma, 8 feet. But the very first thing I'm going to do is I'm going to give this some thickness. So I'm actually, instead of going up, I'm going to go down, let's say 8 inches. The next thing I'm going to do is, instead of just extruding this piece directly upwards, I'm going to offset from this larger perimeter to create the inside face of the wall. Now the best tool to do that is this offset tool right here. If I click that, then I can select within any field and click once, and then from then I can drag a smaller shape of the exact same geometry, but I can specify the offset thickness. So in this case I'm going to type in 6 inches and then click enter, and again, it's going to give me a smaller square which is exactly 6 inches inset from the larger square. Now at this point, instead of extruding the entire face, I can just extrude this outside thickness. And let's say I wanted that exactly 8 inches as well. Oh, sorry, not 8 inches, 8 feet. Now, if we look from above, it's a very different kind of room, where here you have paper thickness, here you seem to have real thickness. Now here's the catch. If you delete this top side of the wall, you'll see that this is actually fake thickness. It's actually just two paper thin walls that are exactly 6 inches apart. But as long as it's a solid piece that's completely surrounded on all sides, there's no way you can really tell. So this really is the best way to do thickness in SketchUp, where other programs like Revit will automatically give walls thickness. But if you're going to be working a lot in between, you want to make sure that you're constantly modeling both models with the real thickness of the walls. At this point, you can come back in and create your door. So let's say I want it 1 foot from the edge. I also, remember I added 8 inches from the bottom. So I'm creating lines to give my start point for a rectangle, which will ultimately be my door. And now, if I just punch that hole, I'll still have the interior wall. So what I'll do instead is I will use the push-pull tool and push back into the face. So these are essentially the same room, but radically different in terms of modeling methodology. Here you have paper thin everything, which is technically architectural space, but is not very useful in any other sense. And here you have real constructible space with thicknesses. And you'll see that they are actually very different. So you don't want to run into the mistake of starting in SketchUp with your conceptual design, going to a pretty developed stage and then moving over to Revit where there's suddenly thickness to your walls and your ceilings and floors, and you realize that a lot of your dimensions are actually much too small because you didn't account for thickness. Now, this is a simple exercise, and I think most people already know this feature. If you have any more questions on how to model accurately in SketchUp, go ahead and ask me questions. I'll be continuing to make more videos based on the questions I get over the course of the project. At this point, I wanted to show you a couple of things. This video is on YouTube, and we're going to start to build a really comprehensive YouTube channel in which you can find videos of actual documenting of the events, or SketchUp videos, any videos I make to help you guys out. So definitely add this channel, subscribe to it, be friends with us, and we'll keep you guys updated in a very good way throughout the whole project. Another thing you should check out is the PBL website itself, pbl.stanford.edu. Here you'll see a lot of different research goals and activities that PBL is engaged with alongside with the AEC class. On the AEC class specifically, you'll see a project gallery where you can see all the projects from past years. You can actually download the presentations they make for the midterm and the final presentation, which are going to be very useful in helping you get a context of what you're going to be making during the course of this project. You can also check out the Twitter feed, which is right over here. And if you click follow, then you'll definitely be able to stay the most up to date with everything that PBL is about and all the reminders for different aspects of the project. So definitely do that. You'll also be able to see a gallery here of pictures from especially last year. This is the year that I was taking part. I took a lot of pictures and I posted them up so you can get a sense of what you're in for, I guess. In the same vein, we have a Facebook page, Stanford PBL Lab. You should be able to find it pretty easily if you search, but you'll see lots of interesting links to not just AEC content, but all kinds of interesting virtual collaboration and AEC work happening in the industry. So definitely add this as well. We also will have a Google Plus with the same idea. Ultimately, there's many, many different ways to stay connected online. I just wanted to show you a subset of those. And definitely don't be afraid to ask for questions at any point during the project. We're always here to help. And I hope you have a really great experience in PBL.